Okay, now that we're getting started, well, one of the basic questions, if you have never ever thought of using text analysis or NLP before, it's kind of where do you find text data? And I mean, the short answer, as I put it here, is everywhere. It can be like the possibilities are endless. It can be a speech, and that's what we're going to do and what we're going to use. It can be also a peace agreement, like for my research, but it could also be a treaty. It could be a newspaper article. It could be an open survey question. So assume you do have a survey question that is open-ended and people are answering that, and you want to know which topics these questions are about. You could potentially use a topic model to kind of get something out of that. But it could also be tweets. People are using tweets to analyze stuff. It could be a website. It could be a text. It could be whatsoever. As I said before, possibilities are endless. And what you need to know about text data before is that it kind of comes in different categories. Just kind of try to describe it here for you. Because where you can think of text data, you can think of it as documents, which is like a bundle of different texts, basically. But it could be also only a paragraph, or it could be also only one sentence, or it could be even only one word. And these are all important things to keep in mind, so that you're like kind of know what you're talking about. And you're going to see in a second why this is so important. Because if you do have a bundle of documents together, that's what we call a corpus. And that's basically your data set that you're working with. It's a corpus, and that's what you read into R, and we're going to do that in a second. And then you're going to do something with that. And then at the end, I just don't want to use the word because I haven't introduced it yet, but in the end, you're going to get a matrix, like it pretty much looks like a data frame, like the thing that we used to work with. Okay, so we do have a corpus, which is a collection of documents. And then we have tokens. And tokens here, it's one word, but it could be also a couple of words, but it could also be like more than just a couple of words, a sentence, it could be a paragraph, it could be like many different things. So even though for most of my research, it's just a word, it's not just named word, but it's named token, because it can capture many different things. And then one other thing that comes with these tokens is you can split up the text into different tokens, and that's what is called tokenization. And that's what you see here. So we do have the sentence that we had before. So Leah is planning to go for a run on Saturday, and we just like wrap the text into its single components. So Leah and is and planning and to go and whatsoever, and so on and so forth. And then something happens, and that's called bag of words, where you just throw in all the words in a bag, literally, or not so literally, but that's how you can think of it. Like one important thing that happens here, they go into the bag as an unsorted collection of words. And so the order of the words, whether Leah was first or last, and whether run was first or last, it doesn't really matter, because we're not interested in that sense in the direction of the words in the sequence, but just into every single word. And it doesn't have to be always like that, and we're going to talk about that during the talk really briefly, because like this bag of words, or it's also called tokenization, is something that comes with its limits. Because obviously, if you don't have the order of the words, you probably miss some important in the line in between things. Is not going for a run, for instance, means something totally different than is going for a run. And it's just the not that is in between going for not going for a run. So these are like, people just assume that it's this is how it, like they don't just assume it, but that's how it works if you use bag of words. And a lot of people do it, and it's a good way to do it, but it has its limitations, and you just have to keep them in mind. And that's why I'm kind of reiterating them here, because that's one thing, like when I started doing these things, I had a hard time to really understand. I mean, obvious consequences are the ones that I just mentioned, but to really get it and to understand why it's okay to do it that way, because everyone was just doing it, and I was like, but it has its limitations. Yes, it has. And these are like things you have to just to keep in mind. But coming from this bag of words, assuming that this is the way to go, and this is the way to go for today, because it's just an introductory thing, we then generate, based on the words that we have, on the tokens, we generate something which is called a document feature matrix. And I just described it here, how you do it. You basically split the text into its words, get your bag of words, and then you count per text how often each word occurs. So I just like did it here. For instance, run in the document A appears throughout document A 4 times. And in document B, there is something like how to make a perfect drink. You need a lemon, ice cubes, Coke, whatsoever. And there I count drink and assume that drink occurs 5 times in that word, but running is not part of that text. So this kind of gives you an idea, probably already, what the text could potentially be about. But in the end, you get a really long matrix, and you're going to see that once we do it with our text that we're using for this session today. And you're going to see there's so many different and endless words. So basically, each word is going to be counted, and you have the words on the columns and the documents on the rows. And that's how a document feature matrix is organized. Okay. And then there are 2 last and important things that you can do with the text once you have it in your document feature matrix. The first one is stemming. It's basically just what the word says. It means getting the stem of the word. So here I have planning, planner, and plans, and the stem is plan. And then there's another thing, it's called lemmatization. And that basically means getting the meaningful stem of the word. Because for studying, and study, the stem would probably be stud, which doesn't really make sense. So here study is more of the meaningful stem of the word. But that's something more advanced, but it's a term that once you're into this text analysis thing, you're gonna meet it over and over again. And so just that you know what it means. So these are the basic introductions. We do have tokens, we have the tokenization where we get the bag of words. We do have the document feature matrix, which is the thing that we're going to use for our analysis. And we do have stemming and possibly also lemmatization. Today, we're only going to do stemming, but yeah, lemmatization is just for your information that it also exists. Using these things, we can analyze basically everything. So I did a project with a friend for a hackathon where we basically, we built a Shiny app where we wanted to see how similar texts are to each other, for instance. We basically used the very same techniques that I'm going to show you today. But I also have another project where we analyze the speeches, and we're going to use the speeches at the UNGD. And they are based on a really, really large data set by Mikhailov and colleagues. And I linked it down here. So if you click on the slides, you also get the link to the data set if you want to use the full data set, because for this session here, I have a reduced version of the data set only. So this is kind of the plan, what we're doing today. I picked 2 things that I wanted to show you. I wanted to show you classification, basically, first on known categories and then on unknown categories. And for the known categories, we use dictionary-based approaches, and we do it first with the topics and then with the sentiment. And for the unknown categories, we basically do topic models, and here we do a special one. It's called structural topic model. So the known categories are basically what you know is supervised, and the unknown are obviously unsupervised. So this is kind of the roadmap for today. And again, as I said before, it's a really quick intro into what is out there. And I'm going to show you at the end what the possibilities are once you got these skills, what you can then do with these things, because it's so great because you have so many different things that you can do once you know how things basically work. And it's not so complicated to add on to these skills. Okay, so first we want to talk about quanteda. Quanteda is the package that we are using. And quanteda stands for quantitative analysis of textual data. So it's basically, it's just these letters make quanteda together. And it's, how I put it here, it's a fully featured package that allows you to easily perform NLP tasks. And the beauty is, within the quanteda environment, you have basically most of the functions that you want to have. They are already in there. So once you do all the important steps that you always have to do when you do text analysis, which is called pre-processing, you can also perform them within quanteda, but you can also use the output of quanteda and put it into other packages. And you're going to see that for the topic model. And you're going to see that basically for the topic model, how you can export the things that you did in quanteda. And obviously there are alternatives. So there's a package called TM, and that's which I used when I started learning that. It's like, it kind of feels more like, at least that's from my memory, it feels like more using base R versus using tidyverse. So this would be, for me, like how I would describe the difference between quanteda and TM. And then there is a package called tidytext, which is really great because it provides you the integration into the tidyverse, obviously, as the name suggests. I guess it's just path dependency for me that I didn't go for tidytext. And also when it comes to pre-processing, I kind of, probably they changed it during the time, but when I gave it a try, it was kind of difficult, at least for me, to get the hang of how they do the pre-processing, because I couldn't really figure out where all the steps that I usually do were in that package. But that doesn't mean that it's like not good. I often use it to kind of do the analysis there as well, because it offers some features that quanteda doesn't have. And then there's another one that I've never used, but it's often recommended, so I put it here. It's called corpus, and it's good if you want to do part of speech tagging. Okay, so but there are even more packages. It's just these are the ones that are like kind of the most prevalent ones that often occur. And again, there should be, I thought I had put like links behind that. Okay, there are no links, but these are the package names. You can just look them up. Okay, so how do we use quanteda? It's basically just always this very same workflow. So you import your data, you build your corpus, which is again the collection of documents that you have. Then you do this magic pre-processing of your data. And in the end, you do the document feature matrix, like to get the matrix where you want to do the analysis with. And how you do it is what I'm going to show you on the next slides. This is here the document feature matrix again in a like larger setting, but you're going to see it in a second. Okay, so like how do you import the data? Obviously, you load quanteda and then you load the data. I store the data in an RData format for you. Often it comes in text data format. And I also link you a blog post in the very end where you do have a guideline how to read in text data, because this can sometimes be a bit tricky, but there's I would say, really nice template how to do it that you can just copy, paste, and tweak and adjust to what you want to have. And then once you have the data, you can generate the corpus. And that's basically the very first line that you have in the top, where you just wrap corpus around your data object, and then you get the corpus. And you're going to see once we do go through the code how a corpus looks like. And a corpus it's not just the text, but a corpus also has stock vars, which are like some kind of meta information about the text data that you have. And you can also assign new doc vars to the corpus, and you do that with the doc vars command. And what we basically do here is we do add an identifier to the corpus. But we're going to see that in a second in the real code. And then, like as I said before, the magic pre-processing comes into play. And what we have here is basically you take your corpus object, which is my corpus, and then you can just choose whatever you think is best. You usually remove numbers, punctuation, symbols. If you have Twitter data, you would probably also remove URLs, and we want to keep doc vars. So this is why it's true, obviously. But there are plenty of possibilities, and you can just look them up also in the help file of quanteda. But these are the ones that I usually use. And then there comes something, it's because of the data that I use. It's scanned with an OCR scanner. So there is some weird symbols in there and I just need to remove them. And this, like how I do it, it's basically based on the guideline that the authors of the data provide. But it can be like, if you use a different data set, it can be something differently. You just have to do it manually. Like you have to look at the data and then figure out what you want to remove. And what it basically says, there are 1,619 features, like words removed here. So we just like our data set got a bit reduced. So this is all the pre-processing. We can do even more. But for now, this is like this should be good. This is, like, as I said, this is the basic things that I always do when I work with the data. And then in the last step, we generate the DFM. And for that, we can also add some things, and that's what we're doing here. So we not only generate the DFM with the token object that we had before, it's here, the token underscore UNGD, but we also lower the text, because for English, it doesn't really make a difference whether it's a capital word that the word starts with or whether it's not. It may make a difference, and thinking about the word May, it may be, right? Like it could be the month of May, it could be a last name like Theresa May, or it could be the May, like the verb. So here it might matter, but it, like, we just assume it doesn't. But there could be obviously other languages, like German, for instance, where the capitalization of a word definitely matters and where it really, really makes a difference. So here you would have to make a different decision. And then what the stem equals true means is basically you stem the word, so you just get the stem. Remember, the planner's plan becomes plan now. And we also remove a couple of stop words. You can self-define your stop words, or you can go with the English language, what I did here. And that basically means like off, and the, like, all these meaningless words are going to be removed because we don't want to have them. So this is for the how to generate the DFM. And now we get a like quick sneak peek into how a DFM looks like. And it's basically like that. So what we have here, we have the docs, which is the document name. And here we have the features, our tokens. And we see in document, in the first document, Afghanistan 2000, way appears once, and assembly, probably it's stamped, appears 8 times, and so on and so forth. And then you can go through the documents and see where the words appear. And this count thing is basically like the counting of the words is basically the thing that we're gonna use once we do our analysis. So that's for that. And then we can do one last thing once we have our DFM. And this really makes sense because you don't want to let your results be driven by some words that appear like really, really infrequently. So you could just drop them. And you also don't want to like let your results be driven by some words that are like super frequent, unless that's really what you want to look at. So here we trim the DFM, and that means we basically remove words that appear less than X amount of times and that appear more than X amount of times. And it's just basically your decision, or like a reasonably, in research you would say a reasonably theoretical decision to do it. So yeah, you just have to decide how often, like how many you want to get rid of and how many you want to keep.
Cosima, sorry
Yeah.
to interrupt you,
No.
but we have 2 questions.
Okay, cool.
So Fred is asking, what are the doc vars?
Yeah, you're gonna see that in a second. I think it's better if I show it you with the code than describing it like right now, because I think that's like, I think it's more obvious once I show you how they really look like.
Okay, perfect. And I think Melissa also have a question, but I think she missed it. But she is asking, how do you remove the duplicate words?
Oh, you don't remove them, you count them. So let's say I do have the text about the running thing, for instance. And if I was really into running, I would talk about running all the time. So this would definitely be a thing that I mentioned over and over again. So I'm really interested in these words that happen so often. So I just count them. I don't drop them. That's basically what what you have here. So for instance, way here occurs 5 times in Angola, but only once in Afghanistan. And I'm interested in how differently the text that I'm using like use these different words. It's a bit hard to explain stuff if you don't have a response, but if that wasn't clear, just let me know and I'm gonna try to rephrase it. But the thing is, you don't drop duplicates, you just keep them. Okay, so once we have our DFM, We can also do some first visualization, and like here's an example of one of these, like I don't know, famous or infamous word clouds that people really like, and it's really easy to do it. And what you're gonna see how this works once we do it in a second. So this is basically the same. It's not basically. It is. It's the very same document or the very same RMD file that you also have. If you've downloaded it, if you look at it on the screen in the HTML version, also the very same. And the deployed one is also the very same. So in the beginning, I just put a bit of like wrap up what it is about and so on and so forth. Then I gave you the overview of the terms in case you're interested. It looks better if it's knitted, promise. And then, and that's the important start. In line 30, that starts the preparation. So I do have all the packages that we're going to use today, and I just put next to them what they are for. So what we're going to do is we basically run that code chunk to load all the packages. It might take a bit for you if you have not already installed them, and they should automatically install if you run that code chunk. I'm gonna probably give you some seconds to do that, and I'm gonna, like, while we're waiting for that, I'm gonna walk you through what we're doing now. So I want to basically show you all the different steps of loading the data, building the corpus, pre-processing the data, and getting the DFM. And I'm gonna like quickly show you also how these different things look like. So how do doc wars look like? What are they? What are they about? And all these things. And you're gonna see that during this run through here. Okay, so first we gonna load quanteda, and then we're gonna load the data. And what we have here is, wait, it's called UN data. Yeah, topic models is the nasty one, but it's better than the other one I thought of. I promise. It takes a while, but it's you're getting there.
Cosima, just Sylvia is saying that she's having trouble installing and loading topic models.
Yeah, I just saw that. It's like really, this is the one package that takes ages. But I thought of a different one to use here, and I was like, I'm not gonna go that way because it really takes a while, and it's difficult to install it. If it doesn't work, Sylvia, you can also follow like the other like options I mentioned instead. They all work. Okay, so let's have a look at the data. We do that here. And what you see is you basically have a data frame because it's our data. It's a data frame, and you have your doc ID. That's the one that you saw before. You do have the text. You see it here. You have a country identifier. You have a UN session identifier. It's the 55th session, and you have the year that follows that session. And these last three things here, like country, session, and year, they're going to become doc vars later. So they're going to be described or give you some more information about the text that you're using. It's kind of metadata. And you can, for instance, use them for the topic model that we use later to give you like your models more insights, more information about the things that are going on there. First, what we're going to do, and that's actually when we use my package, it's really like, it's not actually only my package, but it's also the package from a friend. We both co-wrote it, so I don't want to take all the credits for that one as well. It basically gives you an overview of what you have in your data. So you have an ID variable, it's your country, and you have a time variable, which is your year, and you just see the coverage. So Afghanistan is in all of the years that are covered in the data set, Angola as well, and so on and so forth. It just like all the data starts in 2000 and it lasts until 2018. And that's because I reduced the data set. Otherwise, it would go back, I think, until 1975. And it just takes ages to compile and to run and so on and so forth. Okay, so now comes the magic, or first magic, building the corpus. And we basically do that with the same command that I showed you before. And if you want to look at how a corpus looks like, I have it in line 119. We look at we give us the first lines of the corpus. And we see a message telling us corpus consists, like, because we just got the first 2 documents, and 3 doc vars. And what we see here is we basically see the text that we saw before. On my way to the assembly hall, I was informed by the Supreme whatsoever. And the other one starts with, allow me to begin by congratulating you, sir, on behalf of my, probably. So these are the 2 documents in there. And if we want to see the doc vars, we can just like wrap it around, doc vars around the corpus, and then head around the doc vars. And we see that country, session, and year is the doc var. So this is why I meant it's probably easier if I show it you. And if you see it that way. It's just basic additional information to your documents that you have. Okay, and in the last step, we assign the text number to just have a unique identifier per row. And we do that with that command. And if we then look at the corpus, you see there is this running count that gives you the text number. And it's added to the doc vars. Any questions so far? Or anything that's clear? Anything you want me to specify when it comes to, for instance, doc vars, or I don't know?
Yeah, I think everything is clear now. But we have Mohammed Ali, who is asking: is the DOFCAR is the metadata?
Yeah, basically you can say that it's kind of, yeah, I would say it's metadata. That's how you can think of it. Yeah. Okay. So in the next step, we use our corpus document that we generated before, and we just apply all these different steps that I showed you before. So we remove numbers, we remove punctuation because we're not interested in commas whatsoever, full stops and all these things. We remove symbols. We also remove URLs in case there are some. We split hyphens because we want to keep separate words. And we include the doc vars. And we just do that and assign the whole thing to an object called token. Okay, and then, I mean, it runs, it takes a bit, and it always takes a bit longer if you do it via Zoom. And once it's done, we can have a look at it. And we can see how our tokens look like. So if you remember, here we had this, like a step ago, we just had the full text, like, on my way to the assembly hall, I was informed by the Supreme whatsoever. And now it's split it up into each token. This is what the tokenization is about, right? If you remember. So now we're getting to the back of word thingy. And we do have the same for the other text as well. And then here comes the special step with the where we remove some weird symbols that are due to OCR, and we just run it. Can have another look at it. And here it basically looks pretty much the same, obviously, because there were no weird symbols in here, like in the preview part. But just to show you that it's still the same. And then we can generate our DFM. And that's what we do with the DFM command. We take the token object that we generated before, we lower the words. What you see here, allow is capitalized, the A, the government is capitalized, sir is capitalized, and this should all be lowered now. And we also stem it, and we remove stop words. So like things like the, and so on and so forth shouldn't appear anymore. So we run that, and we check it. So what you see is assembly is small caps now, and there's no on my way and these things. They are all they got all rid of these things because these are all the stop words. And we also have the stem of assembly instead, like it's assemble instead of assembly now. And then in the last step, we can trim the data, as I said before, running that command, and then look again at it. And what we see, and that's actually interesting, so assembly here appeared 8 times, or some subwords of assembly probably appeared less often, and then they got reduced to assemble, and now they got rid of it. So it's not there anymore. Just probably because it appeared not often enough to be part of the DFM. And it's really like how many words you get rid of, how many words you're gonna include. You just have to make that decision in the beginning and justify it, why you do it, the way you want to do it. Okay. And then in the very last step, we can plot and see how our word cloud, or kind of get a first visual impression of how the data looks like. And when quanteda gives us the text_plot_word cloud command, and here we just use our DFM. I don't use the I think I don't use the trimmed one here, just because I want to show you the full beauty of the word cloud, because what you see once you run it, words that appear less often tend to be smaller, right? And if we trim it, we wouldn't have these words in it, but you could also run it with the trimmed one. It just would look slightly different. We do an internal trimming in a way, because we say we only want to have words that occur minimum 3 times and maximum 500 times. And here you do have the distinction. So you have a color-based distinction, how often these words occur. And also you do have a size-based distinction. So the larger the word is, like nation here, this one occurs a lot of times. And I don't know, like it's hard to read, but honor probably occurs only a few times. And the shape of the cloud, I just saw it in the chat. There are a couple of things how you can change that. This is the default one, how you like that you can choose and set, but there are multiple different packages where you can even like, I once tried that for a homepage where we're hosting a workshop and we wanted to have a really fancy and cool word cloud. And I tried one where you could go for, I think it was a symbol that you can just use and just put the word cloud on it. It just didn't look that good, so we went with that one. But theoretically, you have endless possibilities how to change the shape, and there are like many add-on packages that you can use. Excellent question. I just saw the other one. So yep, it's random. So the words change every time you do it. So the one that you have in the word cloud that you have in your HTML file and in the deployed file should also look different from the one that we have here. Oh, I just saw that. I'm not sure if I pronounce your name correctly, Rocio. He asked whether the word cloud in quanteda controls for the effect of the length of the word. So plotting the total area occupied by the word proportional to the frequency instead of the font size proportionally to the frequency. That's a good question. You would need to check that in the function description. Probably they have it in there. Not 100% sure, to be honest. But they do, like, I think, like, visually, they do a really good job to kind of sort the words in a way that it looks good. But if you prefer another stylistic thing, obviously there are, as I said before, plenty of possibilities how to do it and how to plot them. And it's just like, this is not an analysis. It's really like for visualization, getting an idea which word is most frequent and which one is less frequent. Just reading the another question by Melissa. Is there a way of identifying certain subgroups of words to remove them, for example? I'm seeing you have yet in the cloud, for instance. Yep, you can, definitely. So what I did, for instance, for the homepage that I mentioned, we didn't want to have these words in there. So you could, for instance, obviously remove stop words. And you can also identify or define a list of stop words yourself. And we're going to do that later. And just add them and remove them as well. But then obviously, and that's kind of painful and it's tedious, new words appear, right? Because then the frequency of the words, like the relative frequency of the words, changes because you have less words, and then new words come up that you probably don't want to have there. So if it's for visual aspects, it's really quickly done, but to have a really beautiful one and meaningful one, it can take a bit. So just plan a bit of time, but you can definitely remove these things. Yep. Okay. Yeah, here's actually a link to the workshop. I didn't remember that. I put it in here. So in case you're interested, these are the ones that we did for that one. And then I brought you a frequency plot, because quanteda has really like nice features to look at the data. It's not just a word cloud, but you could look at it also differently. So let's say get the top 30 features, and the 30 is defined here. And you can do that with the built-in top features function. We just do that. So here we do have a vector, which has the dimension 1 to 30. And we just generate a data frame object so that we can plot it in ggplot. Oops, here we go, which is now that object here. And there you get also the term and the frequency that was previously in that vector. And now you see nation, it occurs like more than 56,000 times. And assemble, obviously, occurs also quite frequently, but not as frequently as nation. And then I just, I got inspired by I think it was a Stack Overflow post. I posted it up in the beginning of that code chunk so that you can look at it. And then I basically just plot a lollipop plot. And what you get here is it's just a different way of visualizing the frequency, but probably more meaningful because you do have numbers here. You could make even like more ticks if you want to have more ticks. But it's kind of the similar picture, but just differently. So nation is like really often here, unit less often, and so on and so forth. Yeah. So this is the first practice part. Now we're getting back to, here we go, to our supervised approaches, unless there are any questions on the how to start with quanteda part. I'm not seeing the chat anymore. So if there's something popping up, Aifa, please let me know. If not, I will just like move on and see where we get. Okay. Okay, so for the supervised part, well, you have two different things. The first one is like basically both are dictionary based, but the first one is like really dictionary based, how you would imagine it. And the second one is a sentiment analysis. So basically getting the sentiment out of the text. And we start with the dictionary based approach. So, I mean, as I said before, it's like really, it's like a dictionary. So you do have, for instance, defense, and then you have to think of it as you basically like you have a lot of synonyms for defense. So defense could be security, it could be weapons, it could be war, it could be catastrophe, it could be fatalities, it could be all these things. And then you have probably another word and a couple of other words, and all their synonyms as well. And you do have your text, and I have one here, like on an international level, everyone is better off when using the comparative advantages and trade, and countries receive money in exchange for goods. It felt like a bit like going back to my econ class that I had during my undergrads when writing that. But what you basically do here with the dictionary-based approach is you check where words occur that are associated with a certain category. So here we do have, like I put just money, international, and goods in there, and we have international, trading, money, and goods. So there's nothing that is occurring and related to defense in that short snippet of text. So what we would say then is this text is probably about trade, and it's not about defense. So this is on a like really simple level how the thing works, and it's basically not so much more complex. And how you do it in quanteda or in R is basically you define your dictionary. We're going to use a built-in dictionary in quanteda, but there are plenty of other dictionaries out there. So in case you want to do something like differently, or like, I mean, the dictionary also has to fit to the text, right? So if you were doing an analysis on rap songs, basically, you shouldn't use a political science dictionary, because probably the overlap is not really there. Probably it's not, I don't know, I've never done it before. But so like just choose the dictionary that fits to what you have. And then we applied the dictionary to our DFM that we generated before, and we just load it here. So that's what you see there, and that's basically it. And what you then get is, once you look at the dictionary, you kind of like, or not kind of, but what you have here, it's a bit small, and I'm sorry for that. But you have here Afghanistan, for instance, and I just ran a dictionary using like political science, econ related things, and it counts the words. So how often do things occur that are sorted to that category that you have in your dictionary? And what we see, like civil rights and healthcare, is really frequently occurring in that topic, or in that document, sorry, whereas agriculture is not really a thing apparently. So here, like based on this like short and really restricted snippet that we have, you would probably say it's rather about civil rights and healthcare than about agriculture. So we're going back to and we're getting there in a second. And here we go. Because I want to show you how it works. Yeah, lollipop plot. I just saw it in the chat. Lollipop plot is really hard. It's like I don't know why I picked that one. Anyways, so we're in line 285, starting with the dictionary. We're using the Lexicoda Policy Agenda Dictionary. And this is also one thing that I frequently forget when doing these analyses. It's currently only available in Dutch and English. So if you have, for instance, a French text or an English, a German text, or something in a different language, it might not work for your text, right? And multilingual analysis also is a totally different field, and a like way more I would say probably difficult field than just doing like a monolingual analysis, as with English, what I do here. But just that as a side note. So we load the dictionary. I stored it in data, and the LCD thingy is the dictionary format. We load it, and it should be here. So it's in here, formal class dictionary. So that's what we have. And then we add it to our DFM. And we just run that code. And I just generated a new DFM, and we're gonna have a look at it to see what's in there. So what we have is basically, let's look at Argentina. For instance, macroeconomics is really a thing here, whereas like civil rights, which appeared to be rather important in Afghanistan, is not so much a thing in relative comparison, and also in absolute comparison in Argentina. So basically what you have is, it feels like it's all about counting, right? But you have counted all these words and the frequencies, how often it occurs in these documents, and then you add it up, and then you can actually like probably say this text is rather about macroeconomics instead of immigration or whatsoever. And that's basically what the dictionary approaches does. And the sentiment analysis, in a sense, also does it very similarly. And what I'm doing here is I wanted to generate out of this DFM matrix. I wanted to generate a data frame for you so that we can plot it, so that we can really see what is going on there more visually. And what we do to do that, what we use is the convert function. And once you start working with quanteda, you're going to use it all over, like all the time, because this allows you to convert your data, like your DFM, into different data objects. And here we want to have a data frame. And then I just do some wrangling. I rename variables. I select the ones that I'm interested in. I want to have macroeconomics, international affairs, and defense. I use pivot longer to get the data set into the right format so that I can display it. I group by, I generate a share, and I just get the topic as a factor so that I can easily plot it. I just run that, and it's stored in here. And what you see is you basically have Afghanistan and how frequently in percentage this topic occurs. So we do have the relative share now instead of the absolute share. And we do have it like just down for all the countries, all of them in the that were in the DFM and previously in the corpus and in the data set. So now we get to the plotting. We again use ggplot. I'm a big fan of ggplot because it's so like convenient and easy to do it. And what I basically do is I plot the countries on the x-axis and the share on the y-axis. I color it by topic and fill it by topic. And the part down here is basically just adding X labs, Y labs, GG titles, removing the ticks on the X-axis because it's just meaningless. It's so small, you're gonna see it in a second, and I color it. So I'm just running that code. And what you see is here again, remember, are all the countries. And here you see the share. So yeah.
Cosima, we have actually two questions from Rocio. He is wondering how hard it is to find different types of technical dictionaries and already in the right format.
Yeah, that's a good question. No idea. Like, to be honest, I've never worked with technical dictionaries, so I'm not sure. Like, is it like really? Do you mean like technical? Like, I don't know. Like, I was just thinking of software specific things or something like that. I have no idea. So I've just added, I think, no, not here. I've just added a couple of alternatives for the sentiment analysis. I thought I had some here as well, and I have to pass on that. I never used it, to be honest. So like my field is political science, so I go with political science dictionaries. But I'm sure like the last time I gave that talk, someone asked about the rap music. That's why this example popped up in my mind. And people Googled it and they came across some of them really like easily. Oh, socioeconomic dictionary or marketing dictionary. I'm sorry. I've no idea about that. I think they're like, I would have to guess, but I'm pretty sure there are plenty of them out there. And I know also some people write their own dictionaries, but you have to like really make sure that it really captures what you want to have, right? So what you see is basically kind of a distribution of the topics that you have. And what you see, like macroeconomic topics don't occur that frequently. Probably you could add a facet wrap to see how it evolves by year and country, something like that, to get more out of it. But this is just a like first quick and dirty visualization what you could potentially do with that. There's another question. I'm just like trying to follow the chat. Is there any way to do fuzzy matching with dictionary quanteda other than use regular expression like define level? Never done that, to be honest. I mainly use like when for me, these things that we just do now is enough because then I resort to like sentiment analysis and other things. So I don't really use the dictionary approaches to capture the topics of the texts for my research. So I would have to pass on that, but I think even had some pretty cool recommendations with a tidy string disk package by Colin Fay. And I'm like just guessing from the name. I think it should be a good one. Okay, so if there are no other questions on that on the dictionary approach itself, we're gonna do sentiment analysis, which is basically just a different dictionary-based approach. Okay, perfect. So for the sentiment analysis, it's basically like the dictionary-based approach. So you do have a couple of sentiments that are like words that are associated with different sentiments. I put it here really simplistically. So probably excited and happy would be good, right? Best case. And shocked and sad would be negative. And what you then do is you do have your text, and you again categorize and kind of count how often words appear in your text. So happy and excited goes obviously to the positive part, and the sad part here goes to the negative part. And if you want to do that like in action, we're going to use again a quanteda built-in dictionary, which is the LSD dictionary. But there are like multiple possibilities how to add more dictionaries to your data. And here actually I often transition to tidy text, because like at least from my experience, it allows you an easier integration of the dictionary into your corpus, into your DFM, and to really get it working, at least from my experience. And what you then do is here we use the dictionary that we assign to the dict object. And we use only the first two columns because they're happy and sad. They have plenty of other like variations in the sentiments, and we can look at it in a second to see which ones they are. And what we get then once we run it, using our DFM object, we in the end get again a document feature matrix, but now the features are not way or whole or whatever, but it's negative and positive. And it basically counts how often negative things happen and how often positive things happen. And it just counts these things based on the bag of words that you had, basically, because that's how we all started. So, and that's actually one of the downsides of this dictionary approach that I'm showing you today. And I just wanted to make that that clear, because if you have, for instance, today is a sad day versus today is not a sad day, this not totally changes the meaning of the entire sentence. But the dictionary would probably, because of sad, capture it as a sad day, as a negative day. And there are other approaches that do that better. And one is the sentiment R package, and I also linked it in the text. And a friend of mine and we used that for one of our projects, and we really figured that this works way better because it kind of captures these negative, these negations of the words way better than the dictionary that we're using today can do. But it's just basically using the same code that I'm showing you, and just apply it there. So it's not so much different from what we're doing today. That's just like from the downside of this approach. So going back to R, we can go to line 363. And I'm just seeing that there are a couple of questions. No, that's actually only one. Can you normalize with the total number of words that you have, or can you just use the frequency? I think theoretically that should be possible. So what I'm doing now, or like in a second, what the code that I have here, what it does is it adds, we get the relative frequency, like you're going to see that in a second. We get the relative frequency instead of the total frequency, but we're not estimating, or we're not calculating the relative frequency depending on the total number of words that we have in our DFM. So this would be something I would need to look it up, but probably that's possible. I just haven't done it. But we're getting pretty close to what you mean with the relative part. In your example, how does the dictionary handle "I'm not all sad"? Is the word "sad" just captured when the intent actually is likely positive? Not sure if I get the question correctly. If I'm running in a totally different direction, just stop me, please. So in my example, it would be negative, because this is the negation part. And best to my knowledge, it's only sentiment R that can really, like as an easy dictionary or not so easy dictionary, that can really capture these negations. And the one that I have here, it can, like, I mean, it's basically it's basically really like a dictionary. So if there's sad in there, it's negative. If there's happy in there, it's positive. And so it doesn't really capture, the not part. So the negation in the sentence. And that's the downside. But if you're aware of it, I mean, you can account for that. At least that's what you would do in research. I mean, it's not ideal, obviously, but it's one of the best things you can get, or you go to sentiment R, which does it better. But again, as I said before, there's a link to that and you can check it out. Okay, so what I'm doing first is I generate a list of own stop words, and it's pretty long, and there are a couple of stop words in there that or a couple of words that I just don't want to have being evaluated because I don't need them. They're not giving me any meaningful meaning. And this is also like going back to the question that I think, I don't remember the name who asked the question, sorry. But going back to the question on the relative frequency, on the relative frequency compared to the total number of words, obviously once you throw out stop words, it also changes that relative frequency, right? Because you have less words. But that shouldn't actually do that much to your result, but just as a side note. Okay, I'm just adding the stop words to a vector. It's up here. It's 57 stop words. We actually have something like goodbye and good morning and these things. They're all in there. And then we remove them. And this is how you remove multiple stop words. So we want to remove the English stop words, and we want to also remove our own stop words. And that's how you would do it. Just wrap the C around it. And it's basically the same code that we used above to generate the DFM. Okay, let's just quickly run it. And it's now saved in my DFM sentiment. And then again, we can trim it, doing the very same thing that we did before, just overriding the my DFM trim here. And now we can get the sentiment. And I also listed other, like as I said before, I also listed other dictionaries here. These are like really, these are actually ones that are really frequently been used. And they are based on different texts. So let's say you wanna do an analysis on, for instance, like let's say UNGD speeches. You would probably not want to use a dictionary that is built up on YouTube comments, right? Because they could differ so much from the UNGD speeches. So you would just pick the dictionary that works best for the one that you want to, like for the approach that you want to do. But let's say, for instance, I had a project where we were analyzing YouTube comments actually. So having a dictionary that is based on the YouTube comments, excellent choice. It's good to go. But what I would always do is I would always double check with other dictionaries whether my dictionary really captures like similar results as the other dictionaries, just as a robustness test. And that's also what we did when we did our paper and when we used sentiment R. Okay, so what we have here is we're gonna use the data dictionary object, and it's already actually included in quanteda, so we don't have to load it as I did it before. We can, but we can also assign it here. We should also theoretically, let's see, be able to load it. Not really beautiful, but what you have here is you see the first column is negative, the second one is positive, then we have something like neg positive, and then we have something like neg negative, which is kind of tries to capture here the negations. But again, like sentiment R is better in doing that. And because it's like, the reason is actually quite simple, at least that's what the codebook claims, if I remember correctly. They train it on multiple sources and multiple different data sets to capture it really in an efficient way. So what we do is we use the first two columns just for simplicity to run it on our DFM and see what we get out of it. We have a look at the head, like at the first lines. And what we see here is we have the total frequency of negative words and the total frequency of positive words for each document. And what we then do is, as I told you before, the convert command is going to be your best friend. We convert the DFM object into a data frame. And we have it here. And it's all down there. It kind of like counts all the things. And what we do in the next step is we want to get the relative share of negative and positive words based on the total number of words that we have here per country, to kind of get a more like deeper or better comparison, not deeper, but better comparison. And that's what I do here basically. So I use this compound pipe operator to assign it to data again, and then basically mutate and generate the total number of words, get the positive words divided by the total number of words times 100 to get the percentage, do the same with the negative, and then get also the net percentage and to be able to plot it later in a nicer way. You're going to see it, how that looks like here. So let's say for Afghanistan, for instance, we see we have way more, like not way more, but we have more negative words than positive words. And the net percentage is obviously negative here because, yeah, negative outweighs positive. So what I'm doing here is it's basically just a bit of data wrangling again to get the data in a nice format, to be able to plot it, because I want to have the year and I want to have the year out of this doc ID. And I just use some string and substring thingies to get it out. Okay. And I also want to have obviously the country code, because I'm going to show it to you in a second what we want to have. So what I was what I want to do here is I want to plot the first by region. I want to plot the sentiment by region over time. So the x-axis should be the time, and the y-axis should be the sentiment. And then I want to color it by continent just to see what we how it develops over time. I'm just going to quickly run that code so that you see what we want to get out of it, and then I will walk you through the code so that you know what I'm doing. So here we have the time on the x-axis. Here we have the average net sentiment, and then we have the colors here, so the different continents. And what's really interesting, and that's obviously 9/11, one thing where leaders, like state leaders at the UN, tend to be more negative is after 9/11, because they all like state their condolences and probably say something negative about terrorism and the world as it is. So this is the sharp drop here. And besides that, we go up positive with different developments throughout or across the countries and the continents. Okay, so how we got there is basically I used the data that we had generated above, and then I used the country code package. I'm not sure like how frequently you would use it. I use it like every day. It basically gets you based on a country identifier, like an ISO code. It gets you the continent, the region, whatever you want. And it also works with the country name that gives you the ISO code and so on and so forth. So it's like a pretty powerful package that can do that. And I also did a custom match because it's not able to recognize Yugoslavia yet, or it's just not in the package. So you have to do it manually, probably also because it's a coding decision sometimes if you want to have it included in and they just want to raise a concern there. I don't know. So this is what I do with custom match. So this gives me the continents that I'm plotting here with the colors. Then I group by continent and year and get the average net sentiment. And then I just plot it using a line plot, like geom line. X is year and Y is the average, and I color it by continent. And here I just assign the color palette that I want to use. And the last part is like adding some, I'm just seeing there a couple of chat messages. And there, like the rest is just labeling the axis. Yeah. I'm just quickly checking if there's any question. Yeah, I think it was about like the one Melissa asked. Then I might not be able capturing the attention of the speech accurately, correct? Yep. That's actually a really big problem when it comes to using a sentiment analysis with that dictionary-based approach. And it becomes even more problematic, for instance, if you want to capture who is spoken about, right? If you don't want to just capture the sentiment per se of the speech, but if you also want to capture who is addressed. So is it like, let's say, country X blaming country Y, or is it like differently? And that's one thing. What I mentioned before with the bag of words, we don't care about the sequence of words, how they occur. We don't care about these things anymore. So it's really, really, really tricky to capture these things with that approach. It's like one of the shortcomings that it has. Yeah, the compound pipe operator, it's great, right? I just like discovered it when I was working with colleagues like 2 years ago or so. I didn't know it myself yet at that time. One kind of a downside with it is obviously you overwrite your data object here, right? So even though it seems to be really handy, sometimes it's not. And I sometimes fall into the trap that I override what I just didn't want to override because I just added out of reflex. So like me telling from a bit of more experience with that, it can be tricky, but it's really like neat if you don't want to assign it later, or if you don't want to assign it like with the assignment arrows and stuff. Okay. I think these were all the questions. If I've missed one, just let me know. Okay, so in the last step, I wanted to like get more in depth and see like if we can get more out of the sentiment that we have. Again, like results should be treated with caution. And what I did is I just picked a couple of countries and plotted basically the same plot that we had before, but now I used bar graphs, and I'm going to show you what we're going to have. So I plotted it that way using the very same data that we used before. Red here is negative, green is positive. So all above 0 is positive and all below 0 is negative. And what's interesting, actually, what I found interesting is like Germany and UK do have this drop probably in 2001 or 2002, where they condemn terrorism and stuff. Probably, I didn't go into the speeches to check on that. And all the other countries also like have at least a slight drop in there, but they're not as negative as these two countries, which doesn't mean anything. It's just like an interesting finding if you want to have it. So, and the way I did it is, I mean, basically similar as above. I generated the country name, filtered by the country name, and plotted it with a geom call command, which then gave me these things. I'm just quickly checking on the, nope, there are no more questions in the chat. Excellent. If there's something popping up, just let me know. Because if not, we're gonna go to the last part, the unsupervised approaches. Okay, so what we're doing here is topic models, and it works in a way similarly, but also like really differently than the ones that we did before. So you could say, for instance, the first one that we had with the dictionary, where we categorized the macroeconomics and the defense stuff and so on and so forth, that could also be a topic model, right? But it's not what we mean with the term topic model, because a topic model is it's basically, yeah, it's an unsupervised approach. And what you have here is you do have your document, you have plenty of words in your document, and you tell your like the way how the topic model works is you tell your the model how many topics you want to have. Here we said it's going to be 3, and then the topic model randomly or quasi-randomly assigns each word to a topic, and then it goes through iterations through the text and looks at the constellation, how the things are how frequently things occur together, to update each topic categorization that it did previously randomly. Not sure if I was really good in explaining that. If not, I'm sorry. Okay, but to see, like, I just brought a bit of visualization, which hopefully captures that a bit better, what I just tried to describe. So what we have here is we do have words that are now allocated to the topics based on the iterations the topic model went through the document. And what we have done is, in the end, the topic model again counts how often words occur. That's what we have here. And what you can see is the purple words occur the most, and then the green ones, and then a bit more frequent than the green ones are the yellow ones. So the topic model decides that this document basically is topic 1. So you can define the topics of the document itself, but you can also, and that's what we're doing, you can also capture different topics. So what could be topic 1? What could be topic 2? Is topic 1 about defense, topic 2 about climate change, topic 3 about human security, which could also be defense of a humanitarian crisis, probably something like that. And that's what the topic model can also capture. And that's what I'm going to show you in a second. Yeah, here we see topic 1 is going to be part of that document. And these things can actually potentially be helpful if you have the survey questions that I mentioned previously, because then you can classify them and say, okay, this survey answer is probably about topic XYZ. And you can automatically categorize them. But again, like everything, like, I mean, there's no such thing as a free lunch. Everything has a downside, and topic models really need to be evaluated critically, because otherwise it's more like tea leaf reading, and you're gonna see that in a second. But I also added to the Markdown file, I added a couple of resources that help you to evaluate topic models more in depth. Okay, so there, like, these are the two, I don't know, like, these are two like really popular topic models. The first one is the LDA, the one with the unpronounceable name. And it's basically the basis of the structural topic model. So it's basically, I mean, as I said before, for both, the idea is to capture what the text is about. But the second one has kind of an extension. You can add all the metadata to the topic model that you have. So you can, for instance, add the country to get a better categorization of the topics. So probably, like, I mean, I know that from the research. So all the small island countries frequently talk about fishery and climate change, because this is one thing that concerns them. So their speeches are about fishery and climate change. Whereas other countries probably talk less about these topics. So already assigning the country as a meta information can help the topic model to get a better prediction of which topic the people are talking about. So this is actually the major extension the structural topic model has. And how you do it, it's we use the STM package for that, which is here. We then assign the number of topics. We use 5 here. Usually you would probably use more. It's just for compile reasons, because I realized if I go higher, like 20 or something, it just takes ages to compile, and even more so on Zoom. Like, I mean, for my computer, it's pretty fast doing that when I do it without Zoom, but if I do it over Zoom, it's like, it's impossible, and it would be too boring to wait for that. And then your convert function comes in. You convert the DFM that you trimmed to an STM object. So as you see, you can convert all these things into different objects and use them across packages, which is really, really helpful. And actually, that's also why I like quanteda so much, because it's so versatile. And then you assign different components. You assign the documents. You assign what they call vocabulary, and you assign the topic numbers, which is here the topic count. It's K. It's 5. And here, if you add the prevalence, this is the meta information. It's country. You add your data. It's in the DFM2 STM object where I started. It's in the meta part. That's just where it is. And we use the standard initialization type. It's the spectral one. That's what the authors, there's also an accompanying art journal article on that. And the authors figured that this is a pretty good approach to do it, but there are also other ones. And they discuss them in more detail in the journal. So if you're interested in that, the article is really good. And it's really, really nicely written and really nicely summarizes stuff. No, wait, are there methods where the researcher doesn't have to set the number of topics? To be honest, I don't think so, but I could be totally wrong. I mean, like for the topic model package, the STM, you definitely have to set it. And the others that I can think of, you also have to set it. So this is one of because there's also another function in the STM package where you can search for the optimal K. So it's a major part for whatever, setting it up and doing it. So I would say yes. I think that's all the questions. Okay, perfect. Okay, so what we're doing now is we're going to line 604 for the no, I didn't mean it as intruding. It's great. Thank you so much for helping out on that on the chat. I really appreciate it. It was meant positively, not negatively. Thanks. Okay, so what we do first is we load the STM package. I mean, we actually have loaded it before, but I just wanted to make sure that you know which package we're using at that time. And then we assign the topic count, which is again 5. We do it in the next code chunk. Exactly. And then we set a seed because we want to have the topic model similarly across all machines and across all things. So I just used the zip code of Mannheim here, and we convert our DFM to the STM object. And this takes a bit. Once it's done, we do have it here. It's a large list. And here you see, here's the metadata, here's the vocab, and here are the documents. And these are all the documents that we had before. Okay, and what we do now is we basically assign the things as you've seen them on the slides. So you define the documents, which is in the DFM to STM object in documents. Then we assign the words in the corpus. And then we assign the topic count. And we can, for instance, what I've also added here, we can also add the year. So that's how the authors suggested in the journal that I mentioned. And we assign it with the prevalence. And then we also assign the data. It's in meta, as I said before. So let's fold that. So here's all the meta data, all the ones, the doc wars we were discussing previously are also in there. And then we have the initialization type, and we just run it. And while it's running, and it's gonna take a while, you see what it's doing. So it's like beginning the initialization, and then it's doing these iterations I was talking about. So what it's basically doing, it's going through the thing over and over again and classifying these 5 topics that we had. And it's gonna take probably 2 minutes or so. If it takes too long, I've also saved it in a different object before we started. So what you have here, the iteration 10, for instance, is already completed, and it already gave us words that can be associated with potential topics. So what you see here is topic 5 could be African, govern, whatsoever. Now it's gone. And here we have another one, iteration 15 is done. So topic 5 is still African, govern, Africa, conflict, and so on and so forth. And what you see, and that's what people mean with these tea leaf reading thingy, it really easily becomes something like, oh, there could be something like that. Oh, there could be something like this. So this kind of evaluation, not kind of, but this evaluating later the topics model, the topics that you have in the topic model itself is like really one of the things that you really have to pay attention. And one of the researchers at my institute, he just wrote a package on that, and I also linked it down there. It's called Oolong, like the tea, and it basically intends to address this tea leaf reading thing that you have or can have. And basically what it kind of does is it allows you also to manually evaluate your topic, because oftentimes a human coder is obviously way better than a black box machine that just classifies stuff, right? So you would, you would really need to pay attention for that or to that. I was just wondering, yeah. So what I, by the way, what I just linked here, this is the vignette that I really found helpful when starting with the topic models. So in case you're interested and want to know more about that, I definitely recommend to check that out. But what we want to do now is we want to get an idea of what this topic model did, right? And the STM package really has nice functions. You just wrap plot around it, add the type of plot you want to have, and here you want to have first the summary plot, run it, and then you get an idea how often each topic A occurs, and B, you get an idea of which words are most frequently associated with these topics. So what we have here is topic 4 is the most prevalent topic across all 5, and it's region, council, and right, probably. And the least frequently associated topic that we have here is topic 1, which doesn't mean anything because numbers here, they don't tell you anything. So topic 1 does not necessarily have to be the one topic that should be number 1, even though it's called like that. By here, it could potentially be about right, govern, social. I don't know. So to get a better idea of these things, one thing you could do is you could first look up what is in topic 4, for instance. So because region, council, and right doesn't tell us that much, it could be about human rights, it could be about the Human Rights Council, it could be about, I don't know. And what we could do is we can use the command, it's called find thoughts. And it's also in the STM package. We just add our topic model, get or tell the command which texts we want to have. So these are the texts that are in our original data set that we loaded in the very beginning. And this is just for display reasons. So we want to just have one document displayed. And we want to have topic 4 because this is the one that's most prevalent and we want to know more about that. So then once we run that, we get a lot of text, right? So this is basically the first document that is associated with topic 4. And here we see it's about Turkmenistan declaring some constructive and multilateral cooperation with the UN. And we would then go through these texts and read them and see if it makes sense that these texts that the topic model sorted together, or the documents that the topic model sorted together are really together, and see if it really makes sense. And these are the things that, again, people call tea leaf reading. And it kind of really feels like that. It's not really these hard cut methods that tell you, oh, you're below like 5%, this is wrong, or you're above 5%, or this is not what we want to have. We want to have the star, something like that. That's not what, best to my knowledge, what you get here, but it's more of like grouping things, evaluating things, whether they worked the way you want to work, or you want to have them working. Another thing that you can also do if you don't just want to look at the text, but get more of an idea of which words are in each topic. Like, I mean, we kind of get an idea here, but like right, for instance, appears here in topic 4, it's also in topic 3, and it's also in topic 1. So it appears quite frequently, but we want to know what other words are in here. And here we do something which is, again, so great about these text or these NLP and text analysis packages. They are really easy to work with and easy to combine. So here we use the tidy text package and turn our STM object into a tidy object. And we do that with a tidy command. And what we then do is we use some code that I found in a blog post by Julia Silgi. I think that's how you pronounce the name. If not, I'm sorry. And what we do is I'm going to run it quickly, and then I'm going to explain you how we got there. We want to see what's the highest word probability for each topic. So which words occur most within each topic, to kind of get a better idea of what is going on here. And we want to, like, we facet wrap by the topics. We want to have the words on the Y scale and the probability, or the probability on the X scale. And what we do, or what Julia Silgi did here, is basically she grouped by topic, got the first top 10 words per topic, and then did some data wrangling, got like the names of the facet wraps nicely, and in the end plotted the geom call, like plotted it using geom call, did a chord flip, because what you see here is the term is actually on the x-axis, not on the y-axis, and the beta is on the y-axis. And with the chord flip, you flip it, reordered the scales, added labs, and filled it. Actually, that's what I did, because I wanted to have my Wes Anderson palettes. Yeah, so I just used her code, tweaked it a bit so that we can use it, so you get a better idea of what is going on here. So what you have here is we had region, consonant, right, and now we have global, corporation, import, member. It's probably, and this is the tea leaf reading part, and you probably kind of already get it. This is probably about multinational corporation, I would say, whereas topic 5 is, I mean, Africa, here the stemming didn't really work well, as you can tell, is probably obviously more about the African continent. And topic 3, it's, I would say, I mean, terror, time, Palestinian war is probably more about the Israel-Palestine region, so Middle East, and so on and so forth. So you get an idea of what is going on in the topics, then you would go into the texts and use also additionally one of the, like I added, I think 3 different ways how to evaluate your topic models, and then you would do the evaluation of your topic models to kind of get a better idea of what you're like, if it really makes sense what the topic did, what the topic model did, or if it doesn't, and if you should probably change your K, if you should increase it or decrease it, and so on and so forth. Because I mean, it's probably hard to just detect 5, like just using 5 topics and detecting all the facets and the variety in the UNGD speeches. If you, I think the standard data when they do the voting, like when they categorize the voting, I think there they even have 6 topics, and it's just on votes, and you don't get the nuances, what is going on there in the topics. And I do have a research project with a friend, for instance, where we work on these speeches, and we're like, we want to do a topic model. It's a different one than the one that I described here, but we want to like check whether it really works well. So we do some manual coding as well. And what we do here, what we do there, or how many topics, like just from reading the text manually, I think we had like 10 or 11 topics covered. So it's highly likely that 5 topics is not the way to go with these texts. But that's just me telling you from my experience. So what I just wanted to say with that is, you should really read the texts. It's not just a black box that you're using where you throw stuff in and you get something out. Yes, you can. I mean, we got something out and it looks beautiful, I would say, but that doesn't tell you whether it's meaningful. So this validation part and the manual validation as well is really important. So one other aspect that we can also do, besides telling that evaluation is important, you can also plot your topics in a perspective, for instance, because sometimes, as we've seen before, the right part occurred over and over again, right? So we can plot, for instance, and that's what we do here, topic 4 and topic 5 in perspective to see how they are related. And that's what we did here. We have topic 4 here, and we have topic 5 here, and we see conflict, implement, and commit is obviously something that is related to both topics, whereas African is rather topic 5, and this global right part is rather topic 4. So this is something that you can also do by visually inspecting the topics. Then I added a couple of not code examples, but suggestions. It's the search K function to find the optimal K. There's again, I think in the vignette that I linked above, there's more on that, how that works and how to find the optimal K. Then there is, these are the 3 things that I mentioned. There's the STM Insights package, the LDA Viz package. Remember, this topic model basically builds up on LDAs. And there's the Oolong package that I also mentioned before, that all help you to see or to get more out of your topics. And I'm going to quickly show you the LDA Viz, how it works. So the STM Insights and the LDA Viz both call Shiny apps. And once we run that, we do see the Shiny app down here. I mean, I could also open it in a different window, but I'm not sure if you're going to see that then. So what you see here is, you see, for instance, topic 1 and topic 3 really do overlap. And you also have it nicely on the right-hand side in a bar graph, the estimated term frequency within each selected topic. It's red. I just cannot move my cursor, otherwise it goes away. And you also have the overall term frequency. So you do see how the topics get allocated to each how the words get allocated to each topic, and then can also see whether this makes sense or not. And you can just hover over and look at it in more detail. But there are many more options that you can check and that you can look at. So that's basically it with the practice part. I just have 2 last slides for you, because I mean, this is just the beginning, right? So you can do so much more with these tools, and they are actually all the things that or most of the things that you can do now with these with the things that you've just learned, they all build on them. So it's just stacking on top of what you already know. And I brought 2 examples from like probably real life. The first one is the Shiny app that I talked about, and it's also linked behind the image, so you can click on it. And what we basically did there is we use word embeddings to classify, I think it was more than 20,000 abstracts, and to allow people to search based on keywords, based on articles, and based on authors, other similar articles. And it was, as I said before, it was for a hackathon, and it was in the beginning of the pandemic. It was on COVID, like coronaviruses. And we figured that this is something really helpful. And then we found this, like the template for the Shiny app, we found that online. It was from a group of researchers. We also mentioned them in the About section, because they really did a great job. And we just, like, it's not just, it took a while and a lot of computational power, but we computed the similarities, and used our results, implemented them in the Shiny app, and we had that within a weekend, which is like, we really did it slowly. It was not one of these like crazy going hackathon things for us. So it's really amazing how much you can do within just like, I don't know, like I would say 15 to 20 hours. That's it. And then we had this thing up and running. Another thing that you can also do is a chatbot. And this is in Python, but just because there were more tutorials in Python to do that. And there are so many like really cool guidelines that you can use. And I just built that one within like, I don't know, I would say 15 minutes or so. And I'm not perfect in Python, but it's like, I mean, if you know R, it's really easy to translate and read it, and also really easy to adapt the code to the needs that you have. And I just built that chatbot that books me a flight and that talks to me. So they're like, it's really easy and really, really straightforward doing these things. And you can also, that's also one thing with these NLP things. The NLP, most of the advancements in NLP first appear in Python and then get to R. So it really makes sense to also get a hang of Python as well, because it's oftentimes you have to combine stuff. But that's just a side note. Well, and that's basically it. Here are a couple of more resources. They're all like in the slides. I always put the link behind the words so that you can just click on it and look it up. And here's the blog post that I mentioned. It's on Method Bytes. So if you're interested in that, we just updated it because quanteda got a new update and some functions just didn't work. That happens, but it's now up and running, and it should, like, I mean, we used the code here as well. Yeah, so again, if you haven't seen the slides already or haven't seen the material, it's on bit.ly NLP-Tunis. You can all access there. And I would say that's it from my side. I would just stop the screen sharing and see whether you have any questions or whether I missed anything in the chat. Yeah, just feel free to shoot or to ask or whatever.
Thank you. No worries. It was a great workshop and a great presentation. So Mohamed Ali is saying, this is an amazing webinar. Many thanks, ladies. Melissa Morales is saying, thank you, Cosima, and everyone involved in organizing the session. Flavio is saying, awesome, thank you.
Great.
Fred also saying, thank you, great presentation. Melissa is saying, very much looking forward to the upcoming workshops. Sylvia said, I learned so much. Thank you for an excellent workshop, Cosima. And Andrea is saying, wonderful webinar, Cosima, amazing. Samuel is saying also, thank you for great presentation. Rocio is saying also, amazing meetup. Thanks, Cosima, for such great explanation. Thanks, everybody. Ivan is saying, thanks, Cosima. I'll be testing out overview R.
I mean, package building is always bug fixing, right? So you always find something that doesn't work. And the more people that use it, the more bugs you discover. So if there's something, or if there's something that's missing, please let me know. We're really happy to integrate that. And thanks everyone for staying and bearing here and joining the session. I really appreciate it. And thanks for the really, really smooth and so pleasant organization. I really enjoyed that.
So it's an opportunity for us. I would like to invite all of you to our next meetups for February. So 6th February, we have a meetup about RNA-seq analysis with Xui Dong. She will use Lange, Lima, and HR for bioinformatics. Then we will Alison Hurst. It's a joint meetup between us and Our Lady Saudi Arabia. It's an introduction to Didiverse, and Alison Hurst will also use the monsters, the beautiful monsters, to introduce you to Tidyverse. So it will be the 13th of February, 4 p.m. Tunis time. And the 20th of February, we will have Frederick Pro, who will use R and Raspberry Pi to automate social media and data collection. It's 6 p.m., 7 p.m. Tunis time. So I hope that I will see you all in those interesting meetups. Yeah, follow us in Meetup, so we will be able to get notified about those great meetups. So I invite you all to subscribe in our YouTube channel and to activate the notification.